Greetings everyone. Today I want to show you my JETBeam UV flashlight. It takes one AAA cell, and I really do like that form factor, these little AAA flashlights. They're small, you can carry them in your pocket or on your keychain. They don't get in the way. Plenty bright enough for me. So over the years I've purchased a few of them. But I'll move these off to the side because this is the flashlight I want to take a look at. The JETBeam UV flashlight. And I have a AA battery and a AAA battery here for size comparison. So yeah, it's a fairly small flashlight. It's a couple centimeters longer than a AA battery. Well, the neat thing about this flashlight is that it's a 365 nanometer UV type light. It's in the middle of the UVA spectrum. I don't know if you can see the LED in there, but it looks pretty much like an ordinary 3 watt, I guess, LED. I don't know if you can see that. I don't know if the camera will grab a focus on that or not. But anyway, most of the cheaper UV flashlights use the 395 to 400 nanometer UV LEDs, and those are just barely into the visible spectrum. The 365 will illuminate some minerals and chemicals that the 400 nanometer lights will not illuminate very well. So if I turn this on here, I don't know what it looks like on camera. To the eye, it's kind of a whitish, yellowish. I guess it kind of does to the camera. I'm not sure why it's like that. I mean, if you shine it on like this towel here, you can see it's purplish, bluish light. Might be an indicator they might I've put just a small amount of phosphor in there so you can see that it's on. I'm not sure the reason for the color there, but that's just the way this works. Okay, so what I'll do now is a comparison with this JETBeam 365 nanometer UV flashlight and this 400 nanometer. This is one, I took one of those dollar store lights and put 395 or 400 nanometer UV LEDs in there. But I'll have to turn the lights off here to demonstrate. Okay, so what I have here is this piece of paper that has optical brighteners in it so it'll glow under the UV light. On top of that I have ordinary piece of window glass. This is a piece of plexiglass, just ordinary. This is plexiglass that has a UV blocker in it. They use this for art to help protect from fading, and it's supposed to block like 99% of the UV. So I'm illuminating it with just an ordinary LED flashlight, and you can see they're pretty much letting the light through. Okay, so now I'm shining my 400 nanometer light on it. You can see that the ordinary glass and the acrylic, standard acrylic, let the UV light right through. And this here is blocking quite a bit. It looks kind of dark. Looks like it's blocking most of it, most of the UV. Now I'll switch to the JETBeam. And look at that. The glass still lets the UV through, but the standard acrylic is blocking quite a bit, and this is almost black. It's pretty much blocking all of the UV. So you can tell that this is definitely deeper into the UV spectrum than those 400 nanometer type flashlights. A couple more things I'll show you here. I have this tinted acrylic. It glows under UV light, so I'll show you how that works out. have it on this cardboard because the cardboard doesn't fluoresce under the light. So this is with my 400 nanometer light. You can see it lights them up really bright. So now I'll try the JETBeam, and it pretty much lights it up just the same. So in that case you can use both light sources. Now here's some money, and I'll light it up with the 400 nanometer flashlight. Now there's a security strip in there that glows pink, but it doesn't really illuminate with the 400 nanometer light. Yeah, I don't see it at all. But with the JETBeam 365 nanometer, it goes up pretty readily. See that? Lights up. You can see the strip there, right there by my thumb. Well, at least to the eye it's very discernible. So that shows you how some inks, chemicals, and minerals will fluoresce under the 365 nanometer light, and it doesn't fluoresce at all with these typical, more common 400 nanometer so-called UV lights. Well, that's about it for the JETBeam UV 365 nanometer UV light. Just give you a close-up here of it again. I was surprised that it only cost around $16. I got it at a place called Battery Junction. Good place for LED lights, batteries, and chargers. And I look how much the LEDs themselves cost, and they're pretty expensive, so I thought $16 for such type of light is a very good price. Well, that'll do it for this one. Thanks for watching.